Okay, in example 6, we have another tugboat problem. However, it's a little different. This time the two tugs are pulling at different angles. One tug is pulling at a 10-degree angle with the horizontal, and it has a force of 300 newtons, and the other tug is pulling at a 20-degree angle. The question we're asked is, we want the ship to move exactly straight forward. And we know that the first tug is pulling with a force of 300 newtons. The question we're asked to find is, what force must we pull with the second tug, remember at the 20-degree angle, so that the ship will go exactly straight forward? You can imagine that if the second force far outweighed the first force, then we'd see the ship start to turn and veer off course like this because there's more force acting on, a lot more force acting on the right than on the left. So we want to avoid that. We want to know what is the amount of force that will keep the ship going exactly straight ahead. So we're going to analyze this problem, and we'll see that it's actually not too bad to figure out. So because we know that the resultant force has to be straight ahead, okay, we know that the length, or sorry, the magnitude of the green vector here must be so long that it's parallel to what we see in front of us, but it's also just so long that it comes up and only touches the vertical, right? We don't want a vector that far surpasses it and goes this long, because then again the vector's too long and our ship will veer off course. It's not going to go straight. So it's only going to go as long as the second green vector we have here, and so we're calling this the magnitude of force 2. And we have our overall resultant vector that goes straight ahead. We don't know any information about that just yet, but we'll work with that. So just a point of clarification in your diagram here, this 10 degrees is actually down in here. And because of the Z pattern that we find, okay, hopefully you can see that, this 20-degree angle is not only here, but also up here, okay, because of the nice Z patterns. So there's actually a 20-degree angle up there. So what I'm going to do is I'm going to redraw this triangle over here, and hopefully it'll give us a better idea of what's happening. So we have the blue side, the red, and the green. We have a 10-degree angle, a 20-degree angle, a side length of 300, and we want to know the magnitude of this force. Well, hopefully just by looking at this diagram you can convince yourself that we're just a quick sine law away from the answer. We have the angle 20 and we have its opposite side 300. We have the angle 10 and we need its opposite side, magnitude of F2. So we come down here and we have a setup for the sine law. So we're going to have the 300, I'll do a full page here so we can help. So we have the 300 newtons over 20 degrees, and it's equal to the magnitude of F2 divided by the 10 degrees. And multiplying the sine 10 to the other side, we get F2 is approximately 152.3 newtons. So we make a conclusion, therefore the magnitude exerted by the second tug must be approximately 152.3 newtons in order for the ship to travel in an exactly straight path.